we're going to evaluate the integral of x e to the x cosine x by using integration by parts. We're going to split the solution into three parts. The first part would be to evaluate the integral of just e to the x cosine x. The second part is to evaluate the integral of e to the x sine x. And once we have those done, we'll do the third part, which is evaluating the integral that we want, e to the x cosine x. So let's begin with part 1, evaluating the integral of e to the x cosine x. We're going to use integration by parts. Let u be e to the x and dv be cosine of x times dx. From here we compute du, which is e to the x dx, and v sine x. And so the integral of e to the x cosine x equals to u times v, or e to the x times sine x, minus the integral of v du, which is the integral of e to the x sine x. This is a boomerang integral, so we now have to evaluate the integral of e to the x sine x by using integration by parts once. Let u equal to e to the x dv sine x dx. So again, du is e to the x dx, and v negative cosine of x. So the integral of e to the x sine x is equal to minus e to the x cosine x, and then minus a minus or plus the integral of e to the x cosine of x. Let's return to the integral of e to the x cosine x that we started with. It is equal to e to the x sine x minus the integral of e to the x sine x, which we now can replace with, so here is e to the x sine x, and then minus the quantity negative e to the x cosine x minus a minus plus integral of e to the x cosine x. And let's do some algebra to simplify this. Integral of e to the x cosine x is equal to e to the x times sine x plus e to the x cosine x minus the integral of e to the x cosine x. Let's move the integral on the right over to the left, giving us 2 times the integral of e to the x cosine x equals to e to the x sine x plus e to the x cosine x. And all we have to do now is to divide by 2, and we got integral of e to the x cosine x is 1/2 e to the x sine x plus 1/2 e to the x times cosine x. And that's the end of part 1. We'll put this in the box and move to part number 2. So part number 2 of our solution, or step 2, is the integral of e to the x sine x. We've done most of this already, but just record this. Let u equal to e to the x dv equals sine x dx. Therefore du is e to the x cosine times dx, and v is negative cosine x. So let's write this integral as u times v minus e to the x cosine x minus a minus plus the integral of e to the x cosine x. But from step 1, we know the integral of e to the x cosine x already, so the answer is negative e to the x cosine x plus 1/2 e to the x sine x plus 1/2 e to the x times cosine x. And this simplifies to the integral of e to the x sine x, and we can now say equals to minus 1/2 e to the x times cosine x plus 1/2 e to the x times sine x. Let's put this in the box, and we're ready to finish the original problem. We now move to step number 3, evaluating the integral of x e to the x cosine x. We're going to do this by parts. Let u equal to x. Let dv equal to e to the x cosine x dx. du would be 1 dx, and v is the integral of antiderivative of dv, or antiderivative of e to the x cosine x, which we did in part 1. It is 1/2 e to the x sine x plus 1/2 e to the x cosine x. And so now the integral of x e to the x cosine x is u times v, or x times 1/2 e to the x sine x plus 1/2 e to the x cosine x, minus the integral of v du. Since v has two parts, it'll be minus two integrals. First one is 1/2 the integral of e to the x sine x minus 1/2 the integral of e to the x cosine x, which we know, we already done these from part 1 and part 2. So the answer is 1/2 x e to the x sine x plus 1/2 x e to the x cosine x minus 1/2 times negative 1/2 e to the x cosine x plus 1/2 e to the x sine x, and then minus 1/2 times 1/2 e to the x cosine x plus 1/2 e to the x sine x. And all we have to do is do a little algebra here to come up with a final answer in most simplified form. So the integral of x e to the x cosine x is 1/2 x e to the x sine x plus 1/2 x e to the x cosine x, and then minus 1/4 e to the x sine x plus 1/4 e to the x cosine x minus 1/4 e to the x sine x, and minus 1/4 e to the x cosine x. You can see we have minus and plus 1/4 e to the x cosine x that can be canceled, and the other terms, minus 1/4 e to the x sine x minus 1/4 e to the x sine x, will be minus 1/2 e to the x sine x. The final answer then is the integral is equal to 1/2 x e to the x sine x plus 1/2 x e to the x cosine x minus 1/2 e to the x sine x plus c. We'll put that in a box, and that is the answer.